The exponential growth model assumes uninhibited growth, meaning that the value of the functions grows without limit. However, there are inherent limits in the environment like living space, food supply, even predators. So, how can we describe it in reality? Well, this is where the logistics model comes in. It can describe where the growth or decay of the dependent variable is limited. And in a logistics model, the population P after time t is given by the formula P equals C all over 1 plus AE raised to the negative BT, where A, B, and C are constants, with A and C both being greater than 0. Now, if the model is growth, B is going to be greater than 0, and if the model is decay, B is less than 0. Some good facts to know about this is the initial value is always going to be C over 1 plus A, and the carrying capacity is going to be just C. So these will come in handy when answering some of these questions. So fruit flies are placed in a half-pint milk bottle with banana and yeast plants, just so they can feed on stuff and populate. Suppose that the fruit fly population after t days is given by the function P of t equals 230 divided by 1 plus 56.5 e raised to the negative 0.37 t. So we need to state the carrying capacity and the growth rate. Well, the carrying capacity, as I said before, is just C, and C is the top number. So we can say that the carrying capacity is 230 fruit flies. Now, what is the growth rate? Growth rate is B. Now this is already a negative here, and it's a negative here, so we just want the number itself. So we're going to say that B equals 0.37, and we don't want it as a decimal, we want it as a percentage, so we're going to multiply it by 100, and we're going to get 37% as the growth rate. Now we need to determine the initial population, or in this case, the initial value. So the initial value is just going to be C over 1 plus A, in this case 230 over 1 plus 56.5. So the initial population is 230 over 1 plus 56.5. And when we work that out, we're going to get an initial population of 4. So this experiment started off with 4 fruit flies. And what is the population after 5 days? Well, we just take our function here and plug 5 in for t. So zoom out a little bit so we can see it. So we're going to have P of 5 equals 230 divided by 1 plus 56.5 e to the negative 0.37 times 5. And just like with most everything else with exponentials like this, we're just going to let a calculator do our work. In this case, we are going to get 23 fruit flies. You actually get a decimal, but like before, you can't have part of a living creature, so you need to round down. In this case, I'm rounding down to 23.